To solve a trigonometric equation, or an inverse trigonometric equation in this case, we're going to solve it the same way we've solved any equation in the past. So for example, to start getting x by itself, I'd probably begin by dividing both sides by 3, which would leave me then with the equation the inverse sine of x is equal to pi over 3, which I'll leave pi over 3 because hopefully we recognize that as one of our special angles, which is going to be what allows us to get an exact solution, not using a calculator. To get rid of an inverse sine then, hopefully not surprising, I'm going to take the sine of both sides. Sine and inverse sine are inverse operations, of course. So I'm left with x is equal to the sine, regular sine, of pi over 3. And from here, we've done these problems way back when we started this semester, this unit study of trigonometry. So I can go ahead and look up the sine of pi over 3 in the chart that we've made. We put on the plate, we've had that chart in class. The sine of pi over 3, the exact value of that is equal to the square root of 3 over 2. So there's my x value, and I can check these the same way we've checked any equation throughout all of algebra. Take your x value and plug that back in, and just make sure that 3 times the inverse sine of our answer is equal to pi, and we'll check out. Okay, let's take a look at one more example. This problem is very similar with one extra thing at the end that's a bit different. So once again, I'll begin by dividing both sides by -6. To kind of isolate my inverse trigonometric part of this equation. So the inverse tangent of x would have to be equal to, I'm going to go ahead and simplify this to 2 over -6 would just become negative pi over 3 once I simplify. To get rid of an inverse tangent, I'm going to do a regular tangent of both sides. So I'll do tangent here, those will get those to cancel out, and then I need to do the tangent of negative pi over 3 as well. So I'm left with this equation to solve. X is equal to the regular tangent of negative pi over 3. Well, negative pi over 3 is not one of the special angles. It's not in our chart. And so really this is a return to those 3-step problems that we've done in the past, which was 1, to sketch it and find the reference angle. That would end up down here. Look up the ratio and then use the ASTC thing to determine if we're positive or negative. So we can certainly do that if we want to, and if you need help you can go back and find one of those videos, or I can actually take an easier route on this one. And because that angle's negative, now that we know a lot more trigonometry than we did at the beginning of this study of trigonometry, I can use my even-odd properties, if you recall those. The way those worked were, if I had a negative angle, I could always turn that into a positive angle, but sometimes I had to move that negative out front. With tangent, and same went with sine, we considered these odd functions, and that negative sign went out front. If I was working with a cosine function, that's where we just ignore the negative completely. Our answer is the same as it would have been if it was negative. So avoiding the 3-step problem, if I want to do that, all I had to do is find the tangent of pi over 3, which is one of the special angles now, and just make the sign opposite. So looking up that value in my chart, the tangent of pi over 3 would be square root of 3, but because we have that negative angle and it's an odd function, I'll throw that negative back in front, and so my answer is the negative square root of 3. And once again, if I want to check this, it's very easy to do. Just take that x value, plug it back in, and make sure it works out to be 2 pi, or about 6.28.